Hello and welcome. All right, today we're talking about how to build classes, and more specifically how to build a card class. And in the card class, we're also trying to create a tester class for that class. And this class is going to try to mimic a little bit of the behavior of a playing card like you would see in a deck of cards that you might use in a card game. So we're just going to worry about the construction of the card at this point. The way the software is going to work is we're going to ask the user what card they want, and they'll put in a special card code, and then the program will identify that or parse that card code, pull it apart, and then print out in English the suit and rank of that card. That's the idea. Some of us may already have a start on this, but I wanted to start from the beginning and then pick up from where we left off. So let's call this one card tester. Yeah, I maybe start all the way at the beginning. What you want to do is go to New Project and then choose Java Application. We're using NetBeans here to build our program, and we're going to call this one Card Tester. And what NetBeans will do here is create a default project for you and a class that has a main method in it. And again, just a reminder that all Java programs always start with this method call, which is a main method. It's a static method. We'll go over that later, I suppose, what that means. But yeah, the main method is where you put the beginnings of your program. What I like to do is I always like to, this is our tester class, not the actual card class. I always like to write the test first, and that kind of informs me what I need to put in my actual class that I'm going to be trying to test if you write the test first. Now, you can't run the test because the thing you're testing doesn't exist yet, but at least you can kind of map it out. So that's what we're going to do here. Well, first we have to ask the user for a card code. A good way to ask the user for any input is using something called the J option pane. So we say J option pane dot, and notice that the IDE doesn't know what a J option pane is at this point, and that's because we haven't imported it yet, but we'll import it in a second. And then what a J option pane does is actually I didn't write it correctly. This is supposed to be capitalized. I think now it knows what it is. So you can click on this little light bulb here to the left, and it says, hey, do you want to add the import for this from this this class from this package? It found a package in the standard Java libraries that matches this. I say sure. You'll note now that now we have this import of the J option pane, and now it should be able to tell us, what are the different versions, the things you can do with J option panes. And notice there's quite a few things you can do. What we want to do is an input dialog. So I usually just use this one, and the arguments it takes is just some kind of object, but we're going to put in a string and ask the user, please enter a card code. And that will pop a little message up on the screen that says, let's run it, and you can see what it does. I think that's the best way to look at it. Sorry about my voice today. It's a little froggy. That's why I'm not in school today. So it says enter a card code. Now, we're going to use card codes like, this would be like the 10 of hearts, or you could say the 5 of diamonds, or the 6 of spades. They're going to enter a card code like that, and we're going to take that and make a playing card out of it. But notice right now we're just asking for information, but we're not showing anything, nor are we storing what's coming back from J option pane ShowInputDialog. If we look at the help on this, let's see if we can do that. This doesn't always work. Maybe F1. Yeah, it shows the help about help. That's not helpful, surprisingly. Show Java doc, Alt F1. And it'll go out to the internet and find the Java doc on this. Here's ShowInputDialog. This is the one we're using. Shows a question dialog requested by input user. The dialog uses default frame, which also means it's centered on the screen. But the important part is it returns a string. See right here, for the return type for ShowInputDialog, it says it returns a string, and that's the string the user typed in, and that's what we need in our program. So instead of just ignoring that it's returning something, we can store that into our input string. So say string, and we might call it a card code. And then, now that we have this string variable, we can store the result of what the user typed in into that card code. So we just assign the string that's coming back from JAppChampaign into the card code string the string variable called card code. Now we have our card code, and now we can use that to construct our playing card. Now we don't have this card object. Card class yet, but assuming we did, we would say, well, classes, we're going to just call it card eventually, and we might call it a card equals new, and this is just the standard syntax you use for constructing an object. So you use the class name, and then you give it a name you want to call it, a card, and equals new card. Again, it's kind of redundant. And then here you'd pass in, say, the card code. And what this constructor is going to do is going to parse through the card code and try to make a card out of it. So now once we have this card, then it would be nice to put the card on the screen and say, what code is it? For now, let's just do something simple. System.out print line. And we'll ask the card to name itself by just calling its toString method. Okay, and it should put out its string. But again, this won't compile. If we try to run this now, of course, it doesn't work because we haven't defined what card is. It asks this question: one or more projects are compiled with errors. Do you want to run it anyway? This makes no sense to run it anyway because you just changed it and you want to test it how it is now, not how it was before. So there's no point in running it because we don't have a previous version of it anyway. So right now this is in an error state. This project is in an error state. We've got this problem here. It says the card class doesn't exist. So we need to create a new class called card so we can get this program working. But this is generally what our tester is going to look like. We might change it a little bit later. Alright, so the next step is to create the card class. So typically the way I do that is I go up to the package. See, this looks like a little package here. And I right click, and I say new Java class. Now we already have a main method, so this time when it creates this class, we're going to call it card. There's really no need to put the word class on it, say card class, because we know it's a class because it's capitalized, given our style guidelines, so it saves us some typing. We say finish, and we get this coming back. It creates the card class, but notice no main method is included. So let's start building our card class. Typically, I usually start with, well, what data does the card class need to hold in it? And the answer here is, well, we need two things. We need a card has two things. It's got a rank and a suit. Okay, so our rank will we'll store as an integer. Now typically when you make variables that belong to a class or an object, you make those private. So these are called instance variables. Instance is another word for object. So we're going to store this inside our object and make it private. So we have a rank, and then we also have a private suit. We're going to make the suit a string, and it'll just be a letter, I guess. Actually, let's make it a char. Char would be a better choice. And we'll call this suit. What a char is kind of like a string, except it's just a single letter. And then we'll store it in that. So we have a rank and we have a suit. Now, the next step normally on a class is you create get functions and set functions for each one of these. Deciding not to do that here because we're trying to keep this lightweight for now, but typically in a larger class that does more things, we would add those. These are called also known as accessors and mutators. So a get function is an accessor and a set function is a mutator, but again, we're trying to keep this small. So then after I create the accessors and mutators, typically then I create the constructor. So if you remember the form of a constructor when you're trying to define it, is the constructor has the same name as the class. So you would say how to start it. I'm trying to think. It has to be public. Doesn't make sense really to make a private constructor. And then what's weird about classes is they don't explicitly say what data type they return. And so that's something you can't see. And so we don't need to list it here. So we can skip that and go straight to the name of the method, which is, this is the constructor. So the constructor has the same name as the class, which is kind of odd. And then what the card class needs as parameters, well, we're going to pass in a string. That is our card code, right, as our construction parameters. And then I put a set of open and closed curly braces there. Next, we need to start parsing this card code. Now the card code has two parts to it. The first character represents the rank, and the second character represents the suit. And so we're going to have to pull these two characters apart, and then kind of translate them. So first we need to set the values of rank and suit based on what we got. Now we know if it's a number, like, well, ace is going to be the letter A. It could be capitalized or not capitalized. And then 2 through 9 is going to just be a digit. But then 10 is going to be T, Jack is going to be J, Queen is Q, or King is K. And then anything else we're going to flag as some sort of error. Excuse me. So, where to start? Well, we have to get that first character out. What's the best way to do that? Let me think. Probably the best way is to use the strings charat method. Charat's pretty cool because you can get a character at a specific position. So let's do that. We'll create a char variable, and we'll call it, we can't use rank, so we can use stir rank. This is the rank as a string, or as a char rank, we could say that. And we could say this. Okay, we'll take the card code, and we'll ask for what character it is. See, actually guessed pretty well. Char at. And then we pass in the card code, or the index, which is, well, the way you start counting in programming typically is you always start at 0. So if you want the first character from a string, you would pass in a 0 rather than a 1. Very strange. But that's typical across most programming languages, except for a couple. And then that'll get you the first character of the code. And then we do the same thing for the suit, just to be consistent. And here we can say card code dot char at. And we want the second character, so we would say 1, because we start numbering at 0. So the position 0 is going to be the character that represents the rank, and position 2 is the suit. Some people might be saying here, well, why don't we just put it in the suit directly? And we still need to massage it a little bit before we do that. So we have the raw data now, and it's parsed, meaning we've separated the two characters. And now we're going to use them to create or figure out how to set the rank and the suit. So we have to do, let's do the suit first, because that's a little bit easier. We would just say suit, which is a char. And then we want to change this char suit. Let's see what kind of char is a fundamental data type, so we really can't do anything with it. But we want to convert this to uppercase. I'm not really sure how to do this. Look around. All right, so the problem I have here is char is not a class, so it doesn't have any methods on it, so you can't call a method to convert to uppercase. So we kind of have to use a wrapper class. And so there's one called character dot, and we can say to uppercase. And this is a wrapper class, but it has some methods on it for dealing with characters. And we just pass in our character. And now we have our suit. Our suit has been converted to uppercase. The reason why we're converting to uppercase is because we don't really care whether the user capitalizes, like say the letter S for spades, or lowercase s or uppercase s. We want both of them to be interpreted as spades. So we're going to do that. So this uses the character wrapper class. You pass in the character you want to change to uppercase, and it returns a value that represents that character capitalized, and then you store that in the suit class. And so we have our first instance variable now has a value, and notice the compiler says, oh, that's cool, it has a value now. That makes sense. Right now rank doesn't have a value yet, so it's complaining still. So we've got suit figured out. But rank is going to be a little bit more difficult, because here we have a mixture of characters. We have digits, and then we have letters representing the rank. So we need a way to translate that. We also too, like if they put in letters, we want to convert that to uppercase as well. But to do this, it's best to do this kind of conversion, because this is an integer. Now the way we're going to store ranks is ranks are going to be stored from 1 to 13. So all the letters are going to translate to numbers. So 1 will be an ace. Let's say 2 through 9 will just be 2 through 9, but T will be 10, the value 10, the number 10. Jack will be 11, Queen will be 12, and King will be 13. So how do we make that conversion? Well, it'd be nice if we had a method to do that. And so let's write that method down here. What we need is basically a way to say rank equals, And then we might call this method called translate rank character, maybe like that. We're translating that, and we pass in that rank character as a parameter. Okay, so imagine maybe we have a method that looks like that. Okay, so this is called a we have the constructor here. What you have to ask yourself when you're creating a method inside a class is it going to be called outside the class at any point, or is it just internal to the class? Should it be private or public? I'm thinking maybe some point in the future we might want to translate it outside the class, so we might leave it as public. This is where we're going to return a value. We're trying to convert it into an integer, right? This character we're trying to convert into an integer so that we can store it in rank, because rank is an integer. So we need to return that as an integer. And then we'll give it the name here that we gave it. I'll copy it and paste it just in case just so I don't mistype it. So now we're defining a method. What does it need as a parameter? Well, it needs a character of some sort. And we can just call it R. It doesn't necessarily need to have the same name as our instance variable, because or the same name as what we have up here. We can use this if we want, but I'll just call it R for rank. So we're translating the rank character. The best control structure perhaps for doing this translation would be a switch statement. So I don't know if you remember the switch statement, but a switch statement gives you a variety of methods to actually say you have a variety of options, not just two, but many, and you're working with fundamental data types. So switch statements are a good choice. So you say switch. This is what we're switching on. We're switching on the character R, and then switch statements have a body, and inside the body you list out all the different cases. So we say case, and then these are characters, so this is kind of odd. You put single quotes around characters, and we're looking for, remember this has already been capitalized, so if it's an ace, right, then we're going to set a return value equal to 1. Now there's this rule in programming where you don't have multiple returns from it's a good idea not to have multiple returns from a method. So I always like to make a return value that matches the type of the, here we'll say int, matches the return value of the method. So we say int, I just call it return value. And we'll do that. So in the case where it's an A, we would set the return value equal to a 1. So now we've done our translation. Now at the end of every case, you have to you kind of have to put a break there, or it will flow into the next case, and we don't want that. So we would say break at the end of each case. So this is how it would look. And then you do the next case. Well, what's the next case? Well, you could say if it's a 2, that's valid, right? If it's a 2, then the return value is equal to 2. Now there's more efficient ways to do this, but I'm trying to keep this simple, so we're just going to do cut and paste kind of stuff. So basically I'm just going to copy, because 2 and the rest of the numerals are going to be very similar. So I'm going to computer's doing something. Not sure what. Okay, we're going to paste it right here, right, and just continue to do that. So I'll do that off screen so you don't have to watch it, and then you can look at it after I'm done. And through the magic of television, we have them all filled in now. The next ones are a little bit strange, but not super strange. So in the case where we get the letter T, well, that's going to represent this idea of 10. And in that case, we're going to return the value of 10. And we'll just do the values for the different face cards. So here's case. Jack is going to be J. Makes sense. And that have a value of 11. Queen, value of 13, or 12, I mean. And finally, king will have a value of 13. Now this is where a lot of programmers stop right here. They say, okay, I've got them all figured out. Okay, I'm done. But the problem is, what if the user, your user may not type in one of these codes. Maybe they type in the letter Z for some reason. Well, there's no suit called, or rank called Z. It doesn't make sense. That's not part of our code. So we need a way to catch those kind of errors. So what we're going to do is, in the case of anything else, so this is your catch-all case. And so, or the default case. And so you typically would list this last, although it's not necessary to list it last, but you would normally list it last. The problem is we don't have a way, like right now we don't know how to throw exceptions or anything, so we need a way to indicate, hey, this doesn't make any sense. So we're going to actually give it a value of -1, just to kind of warn the user, hey, you're kind of using this wrong because you sent in something wrong and that doesn't make sense. So the user's maybe going to see that and say, oh, okay, maybe that wasn't right. And then we break here too, even though it's the last one. Now we say if it's any of these things, then set it over to this, but if it's not any of those things, then we're going to set it to some kind of indicator to say something bad happened. Now we haven't returned a value yet from this. You know, here's our return value. We set it to all these different values, but we didn't return it yet. So we say return. And if you have a method that doesn't return anything, you can just say return. But if you have a method that's supposed to return something, and in our case our method is supposed to return an int, we would say return our return value. Okay, and that will effectively translate our rank character into a number. And then you see up here, this finally is happy now. Okay, we got a little warning here, which is kind of fun. It says it's overridable. Yeah, so there's probably something I'm supposed to do, probably label this final, but we're trying to keep this simple, so we're not going to worry about that. Okay, so here's our class then. It does the translation, but right now, if we go back to our card tester, we see that our errors disappear for our constructor, but our toString method is still complaining. I didn't write it right. Put parentheses there. You're going to need parentheses. Or you could leave them out entirely and it will automatically revert to a string, but this isn't going to work the way we want. Okay, so I'm going to try this and we'll see, we'll get something kind of strange happening. Here's our option pane. Say I want to put in the 5 of hearts. I would say that. 5 of hearts. And we get this coming out. Cardtester.card@ and then a memory address. That's not really what we wanted. We wanted to actually see it kind of write out the string that represents the card. Though we didn't write that method. What's interesting about Java is if you don't provide a toString method for a class, the default toString method is it just prints out the name of the class and then its address in memory, and that's not very helpful. We want to create our own toString class to to write out its name. So that's the next thing we have to do. So we go into our card class. We're going to be adding a new method. This also will be public. It returns a string, and it's just called toString. And this overrides the one coming from the class. And notice here it says, hey, do you want to add the override annotation? Every object in Java has a toString method, and we saw it down here. It's this. It prints out the name of the class of the object and then its address and memory. We want to override that. And so if we want to tell the programmer who might be reading this code that we just overrode a method from a parent class, we can add this little annotation, and that's helpful. So what do we want to do? We know the suit and the rank. How would we translate this into how do we translate this into a string? Well, this video is long enough, so I'm going to stop right here, and then I'll put this in the next video. So this will get you going, and then we'll do this next part, and we'll get the output we want from our card class.